Today on Stats with Gami, we're going to be learning types of probability. To understand probability, you have to know four basic things. The first thing you need to understand is what is probability. So in every type of probability, you have a sample space. A sample space is a set of all possible outcomes. An outcome is a single trial, and an event is a subset of a sample space. So here we have an outcome. An example of an outcome, using the typical example of a die. So a die has a sample space of 6, because there's 6 possible sides that you can get your outcome from. And let's say in this example we'll be doing an outcome of 2. An event, we can say all evens. And the experiment, or the probability, is rolling the die. Rolling a die. So as you can see, the probability is rolling a die, or the experiment. Your sample space is 1 through 6 because you're rolling the die, there's 6 sides. And the example we're doing is an outcome of 2, and the event is even numbers. But what other aspect you must understand when you're describing probability is the fundamental counting principle. What the fundamental counting principle says is when one event can occur in m ways and a second event can occur in n ways, the number of ways the two events can occur in sequence is m times n. So here we have an example of that. So when you're choosing ice cream, you have many different toppings, flavors, and sauces. What I'm going to do is multiply these times each other. So I have 4 different flavors, which is going to be, so we multiply 4 times 4 times 4. Or you can just say 4 cubed, which gives you 64. So for this answer, the fundamental counting principle will be 64, because 64 different options of ice cream you can choose from. The first type of probability we will be displaying today is classical or theoretical probability. The equation for classical or theoretical probability is P parentheses E, which means event, is equal to number of outcomes in event E over total number of outcomes in the sample space. Here I will be showing you an example of that, because sometimes the equations aren't really good. So the example we'll be using is rolling a die. So the outcome event I chose is to roll the die number 4. So the sample space is 1 through 6. So I put P, probability of parentheses rolling a 4, is going to be 1 out of 6. Because there is one number 4 and there's 6 possible faces to it land on. And this is approximately, in decimal, 0.167. Another example is outcome event B is to roll an even number. P, parentheses, rolling an even number would be 3 over 6. Because there is 3 even numbers in 1 through 6, that your sample space, and that will give you an exact number, which is 0.5. The second type of probability is empirical or statistical probability. Empirical or statistical probability is based on observations obtained from probability experiments. The equation used to determine empirical probability is P parentheses E is equal to frequency of event E over total frequency, or is equal to F over N. An example of that would be if you were to compose a gun control survey. So this is a survey, a stimulated survey. This is the sides people are on. This is the amount of people. So the total amount of people in this case is 177, or the total frequency. So the event is a response of against, and the frequency of this event is 98. So what we're going to be doing is we're going to divide 98 divided by 177, because the total frequency is 177, and the frequency that we're trying to find is 98, or the frequency of the event we're trying to find. And 98 divided by 177 is approximately 0.554. So that would be your answer in this situation. Another component you must understand when doing probability, especially empirical probability, is the law of large numbers. Basically, what the law of large numbers says, in technical words, is as you repeat an experiment over and over, the empirical probability of an event approaches the theoretical or actual probability of the event. What that basically means is the more times you repeat an experiment or an event, the closer you get to the actual value. So let's say you toss a coin 10 times, and 3 out of the 10 times you get heads. If you toss this coin 1,000 times, you will probably reach closer to half, which is the actual probability, because there's 2 sides to a coin. There's heads, H, and tails. So that is basically what the law of large numbers states. The third type of probability is subjective probability. Subjective probability is probably the most easiest to understand and perform. Subjective probability is the result from an intuition, educated guess, or estimates. So subjective probability is usually an estimate. An example of that would be, there is an 80% chance you will get an A on the next exam. Another example would be a doctor saying there's a 90% chance of full recovery of a patient. Subjective probability is usually intuition or an estimated guess, depending on the situation. The final type of probability is conditional probability. This type of probability is the probability of an event occurring given that another event has already occurred. So the equation would be for it, but it's usually probability of P dash A. This is a correct notation which says the probability of B given A. Here's an example of a word problem. You choose a card randomly arranged from a deck. You will pull out the first card on top and it's a 7 of hearts. You replace it. What's the probability that the next card will be a heart? When we're looking at a standard deck consists of 52 cards, which will be our sample space, and it consists of 52 cards, so that will be the bottom, and 13 cards will be hearts. We are not subtracting 1 from 13 because 7 was replaced, meaning it was put back, and 13 is king through ace. And the exact probability of that is 25. So that is an example of conditional probability.